right, these notes are going to be on the basics of trigonometry. Okay, first thing we want to note here is in a right angle, the angle of perspective, and you're going to hear me call it reference angle. Same thing, it's called theta, and so you're going to see this symbol all over the place. You can already see it in the pictures, okay? And this theta, your angle of perspective, reference angle, is going to determine which sides you're going to label opposite and adjacent, okay? Adjacent, we need to know very well as a math term meaning next to. So this is going to mean next to. So when we take a look at these two triangles, we're going to notice that in the triangle on the left, theta is at vertex C. On the right, theta is in vertex A. There will be no theta or reference angle or angle of perspective at the 90-degree angle. Never. It's always going to be in one of the two acute angles. So what that means is your hypotenuse is never going to change locations. Your hypotenuse, as we should remember, is always going to be across from the right angle. So this right here would be your hypotenuse. And on the other triangle, even though the reference angle changed, it's still going to be across from vertex B, which will be your right angle. Now, depending on where the reference angle is, like it says, this is going to let you know, hey, which side's opposite, which side is adjacent. Well, if we're sitting here at reference at angle C, where theta is on the left, we're going to go to the opposite side of the triangle to find our opposite side. Makes sense, right? So in this one, segment AB is our opposite side. But if we take a look over here and we move that theta to angle A, AB is no longer going to be our opposite. Our opposite is now going to be on the opposite side, segment BC. Leaving the last side that we have not labeled yet, our adjacent. And the way you look at it is I'm sitting here at theta right next to me. Think about this side as like a wall. Theta and over here, we're right next to each other, okay? We're like next door neighbors. So right here, bam, there's going to be your adjacent. And same thing over here with vertex area, angle A, where theta is right next to it, right here. All right, that side's going to touch that theta. That's not the hypotenuse. Okay, right here next to it, we have our other adjacent. These are going to be very, very important. Okay, and it even says down here where hypotenuse is opposite and the adjacent. These are going to be important in determining which trigonometric function, really, really fun to say, trigonometric function that we're going to use. There are 3 of them that we use in geometry. These are going to be your sine, your cosine, and your tangent. Okay? When we see them abbreviated, we do not call them sin, cos, and tan. We call them sine, cosine, and tangent. You're going to notice the theta because that is where the angle measurement will go. And then with each one, with sine, you're going to have your opposite side over your hypotenuse, which is the O and the A. And so what has been taught for years is the term SOHCAHTOA. This helps us see which letters go where. So here we would have S-O-H. Sine is your opposite over hypotenuse. Let me get that in a different color. It didn't really show up very well. Your cosine of the angle will be your adjacent side over your hypotenuse, A over H. So that's C-A-H. Your tangent of the angle theta will be your opposite side over adjacent, the O over A, giving you TOA. So here we have SOHCAHTOA. And you're going to see me writing abbreviations in each triangle, first determining which trigonometric function I'm going to use. Now the first 3 problems here, we are simply setting up we're determining which function we're going to use. So the first thing I like to do whenever I'm doing this is find my reference angle, find theta. Okay, in this case, we have an angle measurement right here at 59. You will never, ever, ever use 90 degrees as your reference angle. Don't ever touch that, okay? with this, I can now look at these and say, okay, first thing I look at is I'm going to find my hypotenuse. Let me see if I'm using the hypotenuse. I'm going to go across the 90-degree angle, and I'm going to see here I am using my hypotenuse. So right now I'm going to abbreviate HYP. Okay, later I'll be changing it just to H. And then the other side we need to see, okay, is the X on the opposite side or is it right next to the angle? And we see here it's all the way across on the opposite side. So there's our OPP. So with O and H, opposite and hypotenuse, we're seeing here that we're going to use sine. So this is the way you'll see me abbreviate it. Sine is opposite over hypotenuse, rather than writing it all out. Number 2, my reference angle is right here at 53 degrees. Let me check my hypotenuse first. Across the right angle, oh, I am using the hypotenuse. All right, cool, HYP. Now standing at angle 53, 13, that side, is it on the opposite side or is it right next to adjacent? And it is right next to my angle. So I got my 80J. And looking up top, we're seeing here that the hypotenuse, the adjacent and hypotenuse are used with cosine. So we're going to have the cosine is adjacent over hypotenuse. And these are the formulas. I've told my students that from here on out, we're basically doing formulas. And these are the formulas we will use. The last one here, 64 degrees, there's my reference angle. I just like to put that arc there. I'm going to look first across my right angle. I'm not using my hypotenuse this time. What ends up happening, if you are not using your hypotenuse, it's automatically tangent, because that's the only one that doesn't have hypotenuse. Okay? But we also, knowing it's tangent is great, but we have to remember which one's opposite and which one's adjacent, because we can't switch these. Okay? So we're sitting at 64 degrees. I'm going to go to the opposite side of the triangle to find my OPP, leaving the adjacent one, X, at my 80J. So here we'll have tangent is equal to opposite over adjacent. So let's talk about actually solving these, finding that X. Go to the next page. And we are going to write the equation, and then we're going to solve. So we're going to start off with what we just did with 1, 2, and 3. First things first, let's go to our reference angle. Right here at 41. Okay? Actually, let's write this at the top. Let's go ahead and write our SOHCAHTOA is up here. Sine is opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. All right. So we got our reference angle. Let's go ahead and label our sides now with the 2 that we have. Some people tell you to label all 3. I suggest just label the 2 you have so you're not getting confused. Across our 90-degree angle, that's my hypotenuse. I'm not using it, which again, remember, tangent's automatically it. Okay? If we're not using our hypotenuse, tangent is automatically it. Or if you don't remember that, just label the 2 sides you have. Here's 41 degrees. Opposite side, over here where X is. I'm just going to be putting O's now. And then the 15 is adjacent, right next to it. And then I look up and see, where do I have O and A? It's with your tangent. So here, I'm going to be using tangent. Now, when we fill in the formula, okay, we are going to start off, this is what it's going to be looking like at first. We're going to have the sine, cosine, or tangent abbreviated. That theta is going to be replaced with the angle measurement. Then the O and the H are replaced with what we have for the sides. So here, we know we're using tangent, so we're going to have the tangent. We're just write T-A-N. We're going to open these parentheses, and we're going to put that angle measurement in, that 41. Close the parentheses and equal. Now we have the O over A. So we put O, X, over A, 15. Now, there's a couple ways we can do this. I'm going to go ahead and show you the proportions way. If we turn this into a fraction, we have tangent of 41 over 1. We learn with proportions, we cross multiply. So if I cross multiply here, I'm going to get X. When I cross multiply the other direction, I want to multiply these together. My suggestion is write it with the whole number first, so we don't accidentally put it in the parentheses with this angle. Just trust me. My suggestion, write that whole number first, times, in this case, tangent of 41. Now we need to solve this. The calculator that I recommend is going to be the Desmos Scientific Calculator on the app, or on your phone. Okay, you can do the app. And it's going to look like this. It's going to be this little green thing. So you look up Desmos Scientific Calculator, and this is what it looks like. And I'll show you how to use it as well. So we want to plug in, first of all, we want to make sure this says DEG for degree. It's automatically going to be set for degree. If we have it on RAD, it's radians. We're not going to get the right answer. It'll automatically be degrees. So we need to type in 15 times the tangent of 41. So here I'm going to type in 1, 5. I'm going to push multiply. Your trigonometric functions are going to be under FUNC for function. We had the tangent, so I'm going to click on tangent. We had 41 as our angle measurement. So you go back to main, so you can get back to the numbers, type in 41. And the great thing is you don't even have to press enter. It gives it to you right here. On this, we are going to round to the nearest, I think on my answer key, I rounded to the nearest hundredth. 100 has 2 zeros, so that means 2 numbers after the decimal. So this will be, I'm going to put x as approximately, that's what the little wavy things means, approximately, since I'm rounding. It's going to be 13.04. Note that after the 3, that 9 bumps that 3 up. Okay? So I'm going to press clear all. And let's move to the next one. Here is our reference angle at 27. I'm going to look across my 90 degrees. Oh, I am using my hypotenuse, so I'm going to label H. Standing at my angle, I'm going to say, okay, am I on the opposite or am I adjacent? The 25 is opposite, so I have O. And I look up above and I see O and H is with sine. So I'll be doing the sine of 27 degrees is the opposite over the hypotenuse. So we'll go ahead and start filling it out. We're going to SIN for sine, parentheses. That 27 degrees goes in there. Set that equal to, we have opposite over hypotenuse, all the way over here to the right. Opposite over hypotenuse. So opposite 25 over the hypotenuse of x. So here I'm going to show you again with the proportions. The x has switched places. Okay, it was in the numerator, now it's in the denominator. Let's set this up as a fraction, and let's do our cross multiplying. I like to start with x. So here I'm going to have the sine of 27 times x. So we can just write this as sine 27 times x is equal to the cross product the other direction is just 25. Just as if the sine of 27 was just 27x, you would divide to get rid of it because when you get x by itself, this is multiplication. So you're going to divide both sides by the sine of 27. I do have another way to show you this in a minute. Both sides dividing. And then these will cancel. X will be approximately, and I'm not going to leave you hanging. Let me show you exactly how to do this in the calculator. We're going to have a fraction. So what you're going to want to do is, on this calculator, all the way over here to the right, you're going to have this A over B. You're going to press that. That's going to get you your fraction function. In the numerator, I see 25. So I'm going to type 25. Then I'm just going to tap down the lower section here. I'm going to go to my trig functions, or I'm going to go to function. I'm going to punch in sine, go back to main, and type in the 27. And then here we're going to see our answer, rounded to the nearest hundredth, is approximately 55.07. That 7 bumps the 6 up. 5 or more, up the score. All right, next. Reference angle, right here at 59. Going to go a little bit faster, speed things up. Rewind if you need to. Across the 90-degree angle, I've got my hypotenuse. And then the x is on the opposite side of the angle, so it's the O. And we just saw that we have sine is opposite over hypotenuse. So we're going to set this up. We have the sine of theta, or whatever our angle is, the 59 degrees, is equal to the opposite x over the hypotenuse of 16. So the other way to look at this is, if we look at number 4 and look at number 6, we have x in the numerator. We cross-multiply it up here. Bottom line is, you're going to cross-multiply your trigonometric function with the denominator. So you can just see this, that we're going to multiply that and automatically go straight to x is equal to that 16 times the sine of 59. It's in the denominator, the x is in the numerator, we're going to multiply. All right, so that's all. I just skipped putting it over 1 and cross-multiplying everything. Okay? So now again, we go into our calculator. We press in exactly what we see, 16 times. We go to function, sine, back to main, type in 59, and we round to the nearest tenth in this one, 13.71. Sorry, the glare was there. So x is approximately 13.71. And even if you press enter to get your answer, you just don't have to press clear all afterwards. Okay? Just so you're kind of getting used to using that Desmo scientific calculator. Number 7, we take a look, reference angle. Okay? Hypotenuse is not being used. So let's check this out. Across on the opposite side of 49, your O, and then adjacent, the X is going to be A. So we look up here and we say, okay, what uses O and A? If we're not using the hypotenuse, it's automatically tangent. And we'll go ahead and set up our equation here. We have the tangent of the angle, 49, is equal to opposite 9 over adjacent x. And just like number 5 above, the x is in the denominator, so I'm going to show you the quick thing here. We can do the cross multiply and all this stuff, but there's a much easier way. What's going to happen is if your x is in the denominator, you're going to divide. Denominator divide, d, okay, d and d. Denominator divides. What happens is you're going to take these, you're going to switch them, and you're going to wind up with the x is now over here on the left, and the tangent of 49, here's your 9 up top, your tangent of 49 is now over here in the denominator. Okay? So switch and divide. We'll go ahead and plug this into our calculator. We're going to want that fraction function again. So we're going to press that A over B. We have 9 in the top. We're going to tap down the denominator. We're going to go to our function, tangent, back to main, type in 49, and there we have approximately 7.82 right here. I encourage you to try and do the other ones by yourself. Now, I'm not going to lie, it is going to change up a little bit here because we've used sine and cosine. So, sine and tangent. So let's take a look here. Kind of give away what we're using. Here's our reference angle. We are using the H, hypotenuse. The 9 is not opposite. It is next to. It is adjacent, A. So A and H are with our cosine. So we're going to be using cosine this time. So we'll set up our equation. Now with cosine of the angle measurement 49 is equal to adjacent 9 over hypotenuse x. There's that x in the denominator again. So we're going to divide. We want to take these two and we want to switch them and divide. So x is going to come over here to the left. We're going to have that 9 still in the numerator. Nothing happened there. And then we're going to have cosine of 49 on the bottom. So, again, with the calculator, keep wanting to show you that. Just going to clear everything here. we're going to have a fraction, so x equals, we're going to AB, fraction function. On top, putting that 9. Get down to the bottom, go to your function. We're now using cosine. Go back to main, and we're going to type in 49. And here we're going to have that x is approximately 13 point, be careful with the rounding, 72. Okay, 13.72. That 8 tells us to bump that 1 up. All right, one last one for this video. Move that temporarily. Reference angle. Across from the right angle, I'm using my hypotenuse. And then standing at that angle, I see that I'm using adjacent again. So we are going to be using your cosine. But what has happened now, if you look between 8 and 9, the x and the 9 have switched. So you can see how we're going to get different answers. So using cosine, we're going to have cosine of 49 is now going to be equal to adjacent x over the hypotenuse 9. So we've got reciprocals here. We have 9 over x, now we have x over 9. They switch places. So with the x in the numerator, we're just going to multiply these guys out. Okay? So we'd have x equals, again, I suggest putting the number first, the whole number first, and then 9 times the cosine of 49. Pause when needed. Okay? And our calculator, we just push 9 times, go to the function, cosine, back to main, 49. And we're going to wind up with approximately 5.90. Technically, you don't need the 0 there, but I just always do if it's the hundredths place, because that 4 tells us to leave that 0 alone. At the bottom of this page shows you exactly what I've already talked to you about the multiplying, when you're going to multiply, when you're going to divide and whatnot. If you just remember that the x is in numerator multiply, in m, numerator multiply, denominator divide. Denominator switch divide, those D's, okay? Hopefully this helped. If you need more help, you can search on YouTube for other videos. Please ask your teacher if you have any questions.